Zwagala, Aibo. Shop, the future's calling. Maths and mind colliding. Daily dose of power. AI's here. Siaya. Kubeka, let's learn the new way. Siahamba Pezul. Daily dose of power. AI's here. Siaya. Kubeka, let's learn the new way. Siahamba Pezul.
Hi guys, welcome to the last part of the number patterns. Here we are going to be doing the last question of the June 2026 Limpopo question paper. No, we're doing the last part of the number patterns of the June 2026 Limpopo question paper. What is our question E2 for today?
So our question is 3.2.5, which says calculate the total distance the ball will travel before it comes to rest, which is 3 marks.
So we're supposed to calculate the total distance for 3 marks, okay, guys. Now remember, we attempted to calculate the distance that the ball has traveled, but now we used sum to infinity to calculate that. So we're also going to use that into our advantage. So let's go to the diagram and try to understand basically what's happening here. So if you look at the diagram that we have here, we have the ball which is initially dropped. No?
Yeah.
It's dropped from a height of what? Of
30 meters.
So it's going to travel a distance of 30 meters. That one is fine again.
Yes.
Now it bounces, no? And then it rises. Can you see that again?
Yes.
So when it rises, it's going to reach a height of what?
Of 24 meters.
Of 24 meters. Now, this 24 meters, it's still going to drop again. From the 24 meters, it's still going to travel another 24. Can you see that again?
Yeah.
Now, when we're calculating sum to infinity, tonight, here's what we considered. We considered that the ball is going to start at the height of 30.
Yeah.
And then it went to 24.
24.
And then it went to
19.2.
19.2. So that's what we considered. We said calculate the sum to infinity, and then we checked with this is what the ball has traveled.
Yeah.
But now in this case, we need to consider that the ball is going to be rising and dropping. After the first bounce, the ball is going to be rising and dropping. Now, there are many ways to approach this question, guys, but we are going to choose the one whereby we've already calculated the sum to infinity in question 3.2.2. It was question 3.2.3.
Yeah, it was question 3.3.3.
Yeah, so if we consider that we've already calculated the sum to infinity, we're going to continue from that. So we're going to tell them that sum to infinity.
Okay, sum to infinity
is going to be given by A.
A.
All over 1 minus R.
Yeah.
And then we tell them with our sum to infinity, we got it as 150, remember?
Yeah.
Now you can watch how did we get the 150 on our video of 3.2.3. Okay, yeah. So now that we know that, guys, we're going to tell them this, that remember this question here now, it deals with something totally different because the ball rises and then it falls and then it covers exactly the same distance.
Yes.
So we're going to tell them that our sum to infinity, so we're going to tell them total D. We're going to say total distance the ball is going to travel is going to be equaling to the 150 that we have.
150
multiplied by 2. Why do we multiply by 2? We are counting the rise and the what and the fall. Now, what do we get? We get something like 300.
Yes, 300.
Yeah, but this is not the total distance because if you consider on our diagram, then if you just go to our diagram, then you can see that initially the 30,
yeah,
it doesn't rise, it only falls.
Yeah.
So we need to calculate 31 times. But with this formula that we just use here, we already calculated it 2 times because we considered the rise and the what and the fall. When we said times 2, we were considering that the 30 went down and then it also went up.
Yeah.
So what are we going to do from here? We're simply going to tell them that our total distance basically is going to, let's just say this is because this is not the total distance, it's the rise and the fall. Let's just say rise and fall. We can write it as RF.
Okay.
So it says rise and fall is going to be given by 150 multiplied by 2. So that we're being specific here, which we're talking about the rise and fall.
Okay.
But the total distance traveled.
Total distance traveled is going to be 300.
It's going to be 300 minus the one that we calculated 2 times, but it only did it once.
Yeah.
Which is the 30. So we're going to be minus 30. And then it's going to say that the total distance traveled is going to be 270. Yeah, so the total distance is going to be 270 meters. Okay. Now, guys, another way you could have approached this question here, we're not going to do it, we're just going to talk about it. So another way in which you could have approached this question is to say, Now, let's talk about the rise and the fall. When the ball bounces after the first bounce, so we're going to make our A to be equal to 24 and calculate the sum to infinity. Ne? When you calculate the sum to infinity, we're going to multiply it by 2 because this one of 24 is going to have a rise and a fall, a rise and a fall. So that one, we're going to multiply it by 24, excluding the date. Now, when we exclude the date, then we're going to say multiply by 2. Are you doing it all?
Let's do it.
Let's do it, okay? So if we make our A to be equal to 24, because this one is after the first bounce, we make our A to be equal to 24.
Yeah, our A is equal to 24.
Yeah, so in this one, we're going to tell them that sum to infinity is going to be given by 24.
Sum to infinity is going to be given into 24.
All over 1 minus 4 all over 5.
1 minus 4 all over 5.
And then it says
sum of infinity is gonna be, let's put it on our calculator, by which we're gonna have
120.
24. Let's not try to be
yeah, okay, yeah, let's do the right thing. Let's put it in our calculator, but it's going to give us 120. I have a casual calculator in my mind, so I already have the answer.
Okay, so then the answer is equal to 120.
120, so it's going to say it's 120. So now this is for the rise. Now we can say this one is for the rise. Eh?
Yeah.
So if we multiply by 2, now we're also considering the fall.
Okay. Multiplying it by 2, by which 120 multiplied by 2 is going to be 240.
It's going to be 240. So this one considers the rise and what and the fall. But there's a person that we didn't count, which was the initial drop, which the ball traveled.
Yeah.
So we're going to say plus the 30.
Okay, plus the 30.
It's going to give us still the same answer. You see that?
Yeah, it's going to give us 270.
270, okay. Now, let's go and put it in our AI Senior Marker so that we can check how did we do it. Just put one solution, don't put both of them,
okay,
so that we don't confuse the AI. So let's just put one solution. Now let's go and play the song. While we're playing the song, we're going to put it on the Senior Marker so that we can check what are some of the... Remember, guys, we are the aim here is for you so that you can see what kind of notations we are making errors on so that you don't make the same errors here.
Attention in the studio, let's get the sequence straight. We are talking about the ratio, the multiplier, the R. Don't calculate the drop, calculate what remains. Asambe! They say the ball is bouncing, losing 20 E's on the way. If you multiply by 20, you are throwing marks away. Subtracted from 100, what is left is what we need. 80 is kept, that's the ratio for the lead. What do you keep? Obey. That is your R. We are more now. T2 divide by T1, we taking it far. Don't multiply the loss, no, that's a mistake. Multiply by what is left, that's the total you made. 0.8. And if they give you terms and you need to find the rule, term 2 over term 1, that's the ultimate tool. Geometric means we multiply, we don't subtract the size. Divide the current by the previous, open up your eyes. Whether fractions or percentages, we control the rate. What do you keep?
Hello friend, I'm your mathematics tutor. Please provide your work and I'm here to assist. Marking breakdown. S infinity equals 150. Correct. Carried over accurately from the previous question, 3.2.3. RF equals 150 times 2 equals 300. Correct. M. Mark allocated for the method of doubling the downward sum to infinity. This correctly accounts for both the downward and upward trajectories of the bouncing ball. T_D equals 300 to 30. Correct. M. Mark for logically subtracting the initial drop, O equals 30. Because the ball was dropped from this height, there is no corresponding upward bounce for this specific segment, making this subtraction essential. T_D equals 270. Correct. A. Mark for the final, accurate total distance. Total, 3/3 marks. Coach's summary. What you did well. You bypassed the longer method of setting up two entirely separate geometric series, one for the falls, one for the rises, and instead perfectly executed the double and subtract shortcut. It displays a strong, intuitive grasp of how the S_infinity formula maps onto the physical reality of the problem. Actionable tip. This shortcut is an incredibly efficient strategy to demonstrate to the July cohort, as it saves precious time in Paper 1. To ensure examiners never hesitate to award full method marks, encourage writing the theoretical step out explicitly, such as D_text total equals 2 S_infinity. A. This formalizes the logic perfectly within the CAPS framework.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts. Your comment counts, tell us what you need. Your comment counts, tell us what you need. Find us on TikTok and Facebook. The daily dose of mathematics is the handle. Hit our WhatsApp for the daily prompts. Get more info on 0664 682 9994.